Hey everybody, my name is Ryan Luckie. I am an architect at Cisco with the CX Services Group, and I wanted to talk to you today about a case study for container native storage, specifically an on-prem lab environment. So I just had a few questions before we get started. How many people are using Kubernetes completely in public clouds? How many only on-prem? Anybody trying bare metal? Excellent, you're brave, right? So how many people would say they have a fully integrated C Icd pipeline, like through all their environments, full end to end? Yeah, it's about what I expected. So good on you guys. Like that's the next step for like the holy grail of Kubernetes is that. So a little bit of background. I'm part of a big organization. We have about 600 developers spread across 3 continents, and we are in the process of moving a lot of legacy services and new services into Kubernetes. Basically containerization and then into Kubernetes. So there's a lot of work to be done. The big problem with that is every developer wants a sandbox cluster, a dev cluster, right? And they're stepping on each other's toes the entire time. So what do, right? You've got to figure out a solution. So what we really needed was disposable development environments, or clusters, I guess. And we wanted to approximate what you get in a public cloud or even a private cloud deployment. We had to use available hardware. So we had rack and stacked, a significant amount of hardware and storage devices that we could use and however we wanted to. And it was already tooled. We already had automation around Kubernetes, but without support for stateless workload. So we needed a storage solution for stateful workloads. So the basic goals that we had in mind when we started this process is we wanted to accelerate the adoption and migration of Kubernetes. But what does that mean? We wanted all the developers to build up their chops, right? Get comfortable with the patterns. I don't know how many people use Helm, but building Helm charts and interacting with the different components that we deploy, as well as ancillary components such as databases, Elasticsearch, those types of things. And we wanted to jumpstart the evolution of a truly mature CI/CD process. And we wanted to make sure we could facilitate a painless transition to public cloud or public or private cloud hosted Kubernetes. So the big considerations that we had when selecting a solution is the big one was we wanted to be open source. On my team, this was a really big deal, and we're big proponents of open source. We needed something that was well documented. We wanted something that was easy to deploy. For us, what that meant was we were looking for something that had a well-established, community-supported Helm chart. We were heavily leveraged in Helm, so we wanted to continue to use that tooling. We didn't have access to a management professional, let's say on the team. They were overbooked as it was, and so we wanted to have something that offered a low management overhead. And we wanted something that was relatively performant, but of all these considerations, performance was the least of our worries. And we wanted something that was stable. We didn't want it to be failing because if something's crashing, it's not usable. And the big thing is, you guys heard this a lot today, is support for dynamic provisioning of storage for stateful workloads. Okay, so the evaluation, the things we took into consideration, let me back up. We evaluated three different options. The components or the characteristics that we used for the evaluation was the time to deploy. How easy was it used? Not only for the operators, the people deploying it, but also for the developers who are actually using it. Is there anything that they had to do to actually make use of the dynamic provisioning and the stability? And that's the big thing. So this last one, the resiliency. How many people within their Kubernetes clusters are using chaos engineering? You need to start. Especially with containerized storage, you can, we've heard over and over again today, we can't have pets in Kubernetes. So you should treat everything as cattle, and that includes your storage. You can't make them special. So you should be able to kill, if there's pods that are running storage, you should be able to kill all of them, and you should be able to recover from that situation. And performance. So we use tools like FIO, PG Bench, and different benchmarking tools to gain metrics on the different platforms provide, basic dynamic storage. So we had some interesting findings, and we're pleasantly surprised with some, and we kind of expected some others. So the first thing that we were surprised about is how quickly the ecosystem in this space is evolving. Like, it's changed so much in the last year, it's crazy. And the next thing is things were much easier to deploy in some cases and much more difficult to deploy. But we went with an approach that allowed us to isolate the entire cluster to like 5 pods, right? I should have mentioned earlier that we had all the tooling in place to automate the provisioning of these nodes. Like, we're using KubeSpray, and it's all in vSphere. So I tried to access for a live demo the actual lab environment and didn't go end to end, but I can't access it over this network for some reason. But we're going to go ahead and start an example. It was giving me problems earlier too. I need to. Can everyone see that in the back? Bigger? Okay. So I just set this up. This is in GKE. So long story short, the solution we went with, or we chose for our use case, was OpenEBS. Now, there's some caveats to that. We didn't have any SLAs for performance or resiliency. These clusters were intended to be ephemeral. So they're just purely development clusters. They're actually pre-development clusters. They're sandbox clusters. So there was no guarantee that the data wouldn't be lost, but we were pleasantly surprised with how resilient the actual solution was. So I just deployed this cluster on GKE an hour ago. And the only thing that I've done to this point is Helm init, so we can actually install Helm charts. So let's do the actual deployment. Oops. Okay, so with OpenEBS, we were able to, even on our infrastructure, to stand up, like once you have the Kubernetes cluster established, you could be up and using the dynamically provisioned persistent volumes within a matter of like 5 minutes after it was actually deployed. So what we get here is all the components with OpenEBS, but now, and everything's running at this, well, it's still, yeah, everything's up and running. So let's now deploy a workload. Oops. Oops, sorry. All right, so I'm going to deploy a chart called Stolon. It's basically an attempt to make Postgres more cloud native. It offers replication and all the nice things you like. And all those persistences and stateful sets is what we want. And we're going to have, I think it's 3 replicas for the actual data. Actually, maybe just 2. Oops. I used the wrong storage class. I was playing with SSDs. All right. It's okay. Get PO. So now if we look, you see how this persistent volume popped up? And how it's using the storage class, the OpenEBS Jiva default. So we're almost ready to actually start using Postgres. Now, the cool thing about this is completely independent of the underlying cloud infrastructure. This is mounting to the node's data store or the disks on the node. And you can actually specify different paths or different mount points. So it's easy to horizontally scale. All right, let's watch. I think I'm getting network. No, we're good. All right, so the first keeper is up. And if we describe it, we're going to see like it usually has some mount issues, but it will eventually mount. All right. So now we're connecting to the actual storage right here. So it's still provisioning. That's actually connected. And almost done. So how we'll know that this is actually working? Logs-f. All right. So it's actually sending data back and forth. Now we could connect to it through the service and run pgbench or whatever benchmarking tool you want to use, and the data would get pushed to the PVs. So does anybody have any questions at this point about specifics? Okay. So I think at this point, Uma's going to go over some specific workflows for C Icd.
Yep. Well, maybe I'll just, okay. Thank you, Ryan. Power. Okay, all right. Thanks, Ryan. So that was wonderful, easy to deploy. Just to introduce myself, I'm Uma, working for MayaData. Apart from contributing to projects like OpenEBS, Litmus, Node Disk Manager, also help run our SaaS portal, Maya Online, which is a data management platform for stateful applications running on Kubernetes. So this talk is about to be, it's supposed to be about sharing our experiences on a case study for running CI/CD pipelines. So as part of this big SaaS portal, we use Cassandra, Elasticsearch, Prometheus as the stateful applications, which are actually built totally out of a container native Kubernetes platform, right? So in the interest of time, what I wanted to share was, how did we actually use the tools that we use to build the CI/CD pipelines to get all these stateful applications going, right? So what are the main things that a stateful application need in terms of day 0 and day 1 is ease of provisioning. Developers need to get started very quickly and they don't want to be concerned a lot about storage. Rather, it should be very easy to use. And that's one of the things that Ryan showed up. But really, it comes to how easy it is for you to test your stateful application, bring it into production. For that, your stateful C Icd pipeline has to be very efficient, right? And there are a lot of legacy ways, the standard ways to build this C Icd pipelines, but with changing Kubernetes environments, it should be easy enough for anybody to bring it up and running, right? So a dynamic provisioner, CSI plugin, they're all helping bring commonality into how you would provision storage, and that's how he showed just now. It's easy to instantiate a Postgres database in less than a minute. That's because you got a dynamic provisioner, all the APIs are all sorted out. And the next really thing comes in once the developer checks in the code, how is it really getting tested? What do you need from the ecosystem, right? Is the ability to have the app-aware snapshots and clones, right? So this is how, state is really important for the CI pipelines, right? If you look at the regular pipeline, you might think that you have the code, a single source of truth, you build a pipeline, and you use the blue-green deployment strategy to upgrade, and you are in pre-production staging or staging and production, right? With stateful application, state is really important, right? You deploy your application, it undergoes through, the production usage, and the state keeps changing, right? And when some crash happens, you need to be aware that what was the exact set of data that was when it crashed, right? So state is really the key, and then so the CI/CD pipeline really need to have the state embedded back into the pipeline itself, right? So how do we typically achieve that? Is you take the data snapshots and then push it back into code base itself, right? Apart from the regular code, you have to have a kind of snapshotted versions of the data which you can use to build your CI/CD pipeline. So this is really about making the pipeline itself state aware, and cloud native storage is supposed to be helping this area. Right, so you take the snapshot, clone it, and get your pipeline running, and then cloud native storage is supposed to be providing enough interfaces for the DevOps admin and developers to achieve this need. So what is it that really cloud native storage can do is really about providing how or to make it easy enough to use the snapshots and actually clone the data, right? So what we generally need is, at least what we are doing is incremental snapshots rather than application level snapshot, because it becomes slow sometimes as the data grows bigger. You take the Cassandra type of an application and take a full backup, rather use the storage level snapshot, where it will be usually very, very fast. And then of course it needs some application hooks to query the data. That's what the Google team was saying, that they're going to add application execution hook. In the absence of that, you can use solutions like Heptio Arc or KubeDB. But the idea is you take the snapshot and then you do the incremental versions of the snapshot and then keep storing them. And then Kubernetes already provides this easy hooks to really clone the data that you require. If it's stateful, you use the volume claim template. If it's deployment, you use PVC, and you really get the snapshot, the required version of the snapshot, and then you get the data, and then you start your pipeline. So this is really how the cloud native stateful application will build up. And then it's actually, we started building all these things ourselves because the entire portal is on Kubernetes. And then we thought, why don't we actually make it useful as an open source project? And then we instantiated a project called Litmus. It's a very generic chaos engineering set of tools to build both the pipelines as well as to do the chaos engineering, both in CI/CD pipelines as well as in production, right? So, and we also put it out for a general Kubernetes community, nothing to do with a specific storage vendor. OpenEBS.ci is a reference implementation for how you would build very quick stateful pipelines, right? There is a reference implementation for most of the stateful databases and also the cloud providers. So this is really built using GitLab and Litmus, and as you can see that there are multiple stages right from setting up the cluster. We have KubeSpray, KubeDB, and all that stuff, but it should be made easier for DevOps admins to pull up these clusters on the need basis when the pipeline starts. So Litmus provides all of that, and then you have to have support for various databases. So we do have the community coming in and pitching in. And most important thing is how do you actually introduce this chaos engineering, as well as how do you actually take this data-aware snapshots and put it into your C Icd pipeline. So we got all those things built in. So let's see how easy it is for anybody to take a given Kubernetes engine and then build a pipeline. So it really, this is a reference implementation for GitLab. You could do this for Jenkins as well. So the steps involved are you spin up a GitLab runner, and then Litmus is a set of chaos tools and pipeline builders. You clone it, you select a deployer for a given application, and then you choose a platform. Obviously, you can run on multiple platforms itself. But then you, for example, in this case, GKE, you clone a reference platform and then start tuning to your needs. So if you understand this infrastructure, you can build a stateful CI/CD platform in less than 1 hour, right? And that's how easy it has become using the Kubernetes API and projects like Litmus, right? And you have your chaos engineering enabled stateful pipeline, snap-aware pipeline within minutes, right? So chaos is a kind of a Kubernetes job that embeds all your Ansible engine with some environmental variables using which you can tune. For example, I want to use it for Portworx instead of OpenEBS. You just need to change the storage class, and so same thing runs, right? So you can use it to test it with cluster as well as a reference user, and then it should be easy enough to go and use Litmus for running up a CI/CD. And there are reference implementation which you can use for all the cloud providers. It's right now there on most of the platforms. I just pull up. So this is really the platform that you can see, and pull up a more better one. So this is a completely open source infrastructure. Anybody who's planning to build a stateful application with any storage engine underneath, they could just use it and build it up. So any other question? I just had enough time. We still have about a few minutes for questions. We have 60 seconds. That's what Lisa says. The whole idea is, to share our experiences on Kubernetes ecosystem, how easy it has become to think of stateful applications, not just in provisioning, but actually testing them, building a production level CI/CD pipelines, and moving them onto production. Right.